is the starter. So if you want to pause the video, you can see that we're differentiating exponentials. So straightforward differentiating with an exponential. Then we've got the product rule. Question 2, obviously a longer question. And question 3. So just making you aware that differentiating x times ln3 is just a constant. It's like differentiating 7x. So if you pause the video, have a go at those. Here are your answers. So the answer to number 1. Number 2 is quite a long answer for tangent and the normal. And then question 3. Right, didn't want to do that. Okay, harder implicit differentiation. So far, again, you've been able to differentiate expressions where the power is a constant. So e.g., you've got 4x to the power 10. You can differentiate things like this. You can differentiate them when they're like that. Products, quotients, chain rule. You can differentiate particular functions where the unknown is the power. So e to the x. E is the only exponential function that you can currently differentiate. So the base is the number and the unknown, the power is the unknown or the variable, but that's only for a very particular number, e 2.718. What we're going to look at today is we want to be able to differentiate exponential functions. And when I say an exponential function, I mean something like 2 to the x or 3 to the x. Right, to do this from first principles, you take logs of both sides, natural logs of both sides, and then you do implicit differentiation. So first of all, given that y equals 2 to the power x, show that dy dx equals 2 to the power x times ln2. So what you're going to do is the first thing is take logs of both sides. So ln y equals ln 2 to the power x. The x comes down, so you've got a product on the right hand side. You're now going to differentiate both sides with respect to x. Now, differentiating ln y with respect to x is implicit differentiation. So you're going to differentiate with respect to y, 1 over y, times dy dx. That's going to give you that bit there. And here you've got a product. Well, actually, you haven't, have you? It's just ln2 is a constant. So when you differentiate that, you're just going to get ln2. So 1 over y, dy dx is ln2. Multiply both sides by y. Don't close the entire solution off. Multiply both sides by y. And then replace the y with 2 to the power x. So dy dx is 2 to the power x ln2. So this would be a general formula that you could learn unless it asked you to show detailed reasoning or determine. It's very important that you read the question whether or not you have to do it from first principles. And just here, using the same method, I've proved it. Let's now look at this question here. So if you want to use the formula, and this time I've written the formula down, you can see that differentiate 3 to the x minus 2, it's 3 to the x minus 2 multiplied by the log of the constant ln3. At 4, 9, so substitute in x is 4. So that's going to give you 3 to the 4 take away 2, 3 squared, ln3. So you've got 9 ln3. And that is your gradient. And then substitute in to y minus y1 equals m bracket x minus x1. And I've kept it exact. You could, of course, round those as decimals. Right. If you'd like to pause the video, have a go at differentiating these. Here are your solutions. And now we've got an exam question. So this is an 8-mark exam question. So you've got the curve x squared plus y cubed minus 8x minus 12y equals 4. At each of the points, P and Q, the tangent to the curve is parallel to the y-axis. So if we think, didn't want to do that. If we think parallel to the y-axis, it's going to look, it's a vertical line, isn't it? So parallel to the y-axis, think vertical line. Right, we need to find coordinates of P and Q. Off we go. So first of all, let's differentiate implicitly. Now really, this is actually really nice because there's no product or quotient there. So just make sure that you're careful with your y terms. You're then going to gather your terms together, dy dx is on one side and non-ones on the other, and then you've got dy dx. Now, to be parallel to the y-axis, so if we go back here and have a little think about the gradient, you know that if you've got a line, a vertical line, then your horizontal change is 0. So think vertical line. I'll draw a line in because actually I think it helps me. I hope it helps you as well. So there's your vertical line. Okay, I can't get it quite very easily to make it be the tangent. That's better. You can see that the horizontal change is 0, which means in your gradient, the denominator is going to be 0. Okay, so I'll put that in to help. Solving that, you've got y equals plus or minus 2. Now clearly from here you can see that you've got the line. It's very definite that y is positive. So you're going to be, from your diagram, you can see that y is positive, and so y is going to be 2. So y is definitely 2. Okay, you now substitute y equals 2 into your equation. Rearrange, you've got a lush quadratic. Factorise or solve the quadratic, they don't care how. X equals 10, y equals minus 2. But it asks for the coordinates, so in theory, that's not quite enough. Put them back in with the y coordinate of 2. So that's a good 8-mark question in an exam. And if you now have a go at these two old exam questions, lot of work, 10-mark question, 8-mark question, and here are their mark schemes. Well done. Doo-doo-doo-doo.